Okay, ladies and gentlemen, good morning, and thank you for joining us today on this panel, which will address innovation and new forms of popularization of mathematics. I am Raissa Malou, director of the nonprofit organization Investing in People, which organizes the Science and Technology Week in the Democratic Republic of Congo. Today, I have the pleasure to chair this panel with an exceptional mathematician whom I will introduce in a few moments. But first, let's get some context. In elementary and high school, mathematics is not the most popular field among students. Mathematicians are probably the least understood scientists. Their field is perhaps the most frightening. Yet, math is everywhere and is so beautiful. During this panel, we will explore new ways to make the field more inclusive, more diverse, and perhaps finally reconcile the public with the discipline. To talk about this morning we have Dr. Claudio Landim from Brazil. Good morning, doctor, and thank you for joining us.
Good morning. Thank you very much, Raissa, for taking care of this.
Thank you. We are sorry we should also have Dr. Sergei Rakshin and Dr. Michael Launay this morning, but unfortunately they cannot join us. So this session will be divided into two parts. We will begin with presentation by our speaker on his work and research, and we will conclude with a discussion on three central themes: inclusivity and diversity in the discipline, challenges in mathematics education, and the role of mathematicians in society. Before we move on, I would like to inform our audience that you can post your questions in the chat with your email, and we will forward them to the speaker so he can answer them later. Indeed, because of time constraints, we could not be able to answer the questions live. We sincerely apologize for this. So let's start with Dr. Claudio Landim. You are a researcher in mathematics at the Pure and Applied Mathematical Institute in Rio de Janeiro, Brazil, and directeur de recherche at the Centre National de la Recherche Scientifique, CNRS, appointed at the Université de Rouen in France. You worked as in non-equilibrium statistical mechanics, in interacting particle systems, and metastability. You are also a member of the Brazilian Academy of Science and of the World Academy of Science twice, and a winner of the CNRS Bronze Medal, the World Academy of Sciences Prize in Mathematics, and the Science Education Prize of twice Latin America and the Caribbean Regional Partner. Is that right, Dr. Claudio?
Exactly. Thank you,
Okay,
Raissa.
Great. So, Dr. Claudio Landim, you have the floor for 20 minutes. Thank you.
Well, thank you very much. So let me try to share my screen with you. So here is it. And so maybe let me enter in full screen mode. So today I will talk about the Brazilian Math Olympics of Public Schools, which I coordinate since 2011. So my main concern here will be to present what we do in Brazil and to try to simulate researchers in mathematics from developing countries to adopt a similar Olympics in their countries. In this sense, I'll be very pleased to help them in organizing these Olympics. So you can find me on internet and send me an email. I'll be very glad to provide more details on these Olympics and to help in creating them in your own countries. I will here today try to be, I won't be technical, but if you want more information about the Olympics, there is just a recent published paper on ZDM in collaboration with Gail Fitzsimmons. So you can look at for this paper and you'll see there are more details about the organization and the impact of these Olympiads. So in the beginning, I will present how we organize the Olympics, and then I will try to discuss a little bit about the impacts. You can also find more information on our websites, which is www.obmep, so obmep.org.br. So we run these Olympiads, which has many initiatives. There is a very big exam, which I will present in details. But I want also to stress that we have very important programs in students training, which I will discuss a bit, on didactic material, which I think it's extremely important, because the background you have to keep in mind during all my talk today is that math education is very bad in Brazil. Essentially, we have 15% of students who go to private schools and 85% who go to public schools. And the quality of math education, it's very bad on public math schools. It's not so good in private, but it's better in private schools than in public schools. So our main concern of this Olympiads is to try to improve the quality of math education in public schools. So besides the students training and the exam, we have also this production of didactic material, which is extremely important. And if you go to our websites, you'll go there to program, you'll see that we have a portal, a website in which students can find videos, tests, every type of material to learn mathematics by their own, on the one hand. And on the other hand, also we try to stimulate a new type of math education through solving problems. So every year we published a certain amount of books trying to stimulate students going through math by solving math problems. And then we have also a very important coaching of teachers. So we try to stimulate this teacher to organize the Olympics in their school and to prepare the students for the Olympics. So let's go to the numbers. So my first slide is to try to show you that it's all essentially a universal Olympics, right? Every year you can see here the number of students who participate in this Olympics. It's about 18 million of students which take part every year to this Olympics. So it's a huge program. We have around 55,000 schools which take part, and we are present essentially in all municipalities. So when you see that we don't have 100%, mind that the municipalities who do not participate are not the poor ones in the north of the country. They are in the south, and they don't participate for political reasons. So we have essentially a universal program. The exams, it's performed in 2 stages and 3 levels. So we divide students between level 1, which are students from the 6th and 7th grade, level 2, students from 8th and the 9th grade, and level 3, the students from the 10th to the 12th grade. And the exam, it's organized in 2 stages. In the first stage, every student participates, while only 5% of the best grades participate at the second stage. So let me describe the first stage. So we open an enrollment period so that the schools enter into our website and they inscribe their schools, telling us how many students on each level will participate to the Olympics. This happens during essentially 6 weeks at the beginning of the year. Remember that in Brazil, schools go from March to November. So by February, we open the inscriptions. So once we know how many students participate at each level, at each school, we print all exams of the first stage and we send them to the schools together with the answers to the tests. So the schools receive all these printed exams. The exams of the first stage are multiple choice problems with 20 questions in total for each of these 3 grades. And these exams are applied all over the country the same day. So in 2022, it happened on June 7th. So remember that also in Brazil, so schools run either in the morning, in the afternoon, or in the night. So we have certain schools which apply the exam in the morning, others in the afternoon, and others at night. These, as I said, we sent the corrections also. So these exams, these 18 million exams, are corrected by the teachers of each school, and they select 5% of the best grades to go to the second phase. So they tell us, they send to IMPA, which is organizing this event, what are the students who have been classified for the second phase exam. So in stage 2, as I said, 5% of the students are qualified. Now we have problems. They are applied in 9,000 centers in Brazil, and this is organized by IMPA. So we have divided the country in 70 regions. Each region has a coordinator, and the coordinator is responsible to find centers in which these problems, these tests are applied on presence. So the students go on a Saturday. So this year it will be on October the 8th. They go to one of these 9,000 centers, and they spend 3.5 hours solving these 6 problems. So we have about 1 million students who take this exam on October. These exams are sent to the coordinators. The coordinators invite 20 professors to correct these exams, these 6 problems. And so each coordinator is responsible for around 50,000 exams, which have to be corrected. And they report to us the grades. In view of the grades they gave to each exam, we proposed them a threshold. And the exams who obtained a grade above the threshold are sent to Rio de Janeiro, where IMPA is, and they are corrected a second time by a national committee. So it takes a week to recorrect approximately 25,000 exams. And it is these second and national corrections that we use in order to give the medals to these students. So here, let me show you a picture in Mato Grosso. So this was taken some 6 years ago. It's the second stage in Mato Grosso, which is a state on the west of Brazil. And this is a picture which was taken recently, so in June the 7th, in Roraima, which is a state in the north, in which the students are taking the first phase exam. Then let me say that though it's called an Olympics, we try to keep the level of the problems very low. And we also try to propose problems who do not require a formal knowledge in mathematics to be solved. The idea is that these problems should be solvable if you have an idea of some intuition and if you can, some rationale of mathematics. So here it's a typical example of a problem, of a first stage problem. So Elisa puts 6 dice on the top of a table, as in the figure, and she writes down the sum of all the faces she can see as she goes around the table. The faces of each die are numbered from 1 to 6, and the sum of the numbers from 2 opposite faces is always 7. What is the largest sum that Elisa can get? So it doesn't matter if you were a good math student at your school. In order to solve this problem, well, you can't use really what you learned at school. You have to just figure out what is the problem and solve the problem. So these are the type of questions we propose to the students in mind. Well, these questions are not very difficult because we're not selecting the students who will represent Brazil in the International Olympiads. We are just trying to stimulate and to show that mathematics can be fun, that mathematics can be different from what is learned at schools. So we give each year many medals. So we give, in 2017, I said that it's a public school, so it's meant for public schools. So when the Olympics was created in 2005, only students from public schools were allowed to take part. In 2017, we allowed students from private schools to take part, but we have different classifications for students from public schools and students from private schools. And also inside the public schools, we have very good public schools, schools related, which have a link to the university, other schools which are federal institutes, and therefore we give a limited number of medals to students from these schools. So each year we give 500 gold medals to students of public schools, 1,500 medals of silver medals for students of public schools, and 4,500 bronze medals to students of public schools. And well, the numbers are very low for private, so we give 75 gold medals for students in private schools, 225 and so on for students of private schools. All these students, so we have essentially 8,000 students who get medal each year. And besides the medal, we also give something around 70,000 honorary mentions to the students, because we know that if a student gets such an honorary mention, that stimulates him a lot. So we try to give as many as possible. So the next year of the exam, all students who got a medal, they get a scholarship from our CNPq, which is the research institute in Brazil. It's of 100 reais per month, which is about $20 per month that they get. And mind that the minimum wage in Brazil, it's 1,000, so it's $200. So essentially they are getting 10% of the minimal wage to participate in this student training program. So the students, if they live close to a big town, they participate on site on these formation, on training. So we have every other Saturday a meeting in one of these universities or federal institute. So they meet twice a month. We have, you'll see on the map, more than 200 centers in which this training is proposed. They are directed by regional coordinators, and we have many university professors which are involved. All students who live very far from one of the centers can participate online, so we have also online teachers. So here's a map. So these are the medalists of 2021, which are participating now to the program. So these are the municipalities. Each dot represents a municipality where there's a student which is taking part of this training. And here are the centers in Brazil in which this program is offered. So we have the exam. So we select students. We try to use this exam to detect students which have talent for mathematics. And it's not enough to detect them. We have to train them. So we have this training program, which is extremely successful after the exam. So let me give you two types of impact. So the first one, as I said, I think this exam is able to detect young, talented students. So here you can see a picture of 2006. And here is Tabata Amaral, which I will talk, and here is Gerson Tavares. So this is in 2006. They were 11 years old at that time, and they got a gold medal. Both got a gold medal. So Tabata Amaral has a typical trajectory. Once she's from São Paulo, once she got the gold medal, she was invited to a private school. She had access to a very good formation. She went there after getting many medals in other Olympics. She went to Harvard, where she spent 4 years. She came back to Brazil, and now she has been elected in 2018 as a congresswoman in Brazil. Okay, I won't explain exactly how we elect people to parliament, but let me say that she's from São Paulo, and she was one of the candidates who get the greatest number of votes in 2018. Gerson has a completely different story. So he's the first student ever who got 4 gold medals. And Gerson, what is, I think, extraordinary about him is that he didn't know he was good at mathematics. So the teachers didn't know. He never got a good grade in mathematics. In 2005, when his school enrolled in the competition, he was very surprised that he was qualified for the second stage of the Olympics. And when he learned that, he started to prepare himself by himself to to the exams. Gerson studied at night because during the day he worked to help the family. And he told me, so I met him later, that in one of these years, he didn't have classes all Fridays because the professors didn't show to give the classes. So starting in 2005, after the gold medal, he started to learn by himself mathematics. He discovered mathematics. And a few years later, so in 2009, he entered in engineering in the best university, so university in Brazil, the University of São Paulo. So these Olympics, as I said, by proposing problems which do not require formal knowledge in mathematics, is able to detect and to stimulate these young, talented students. In this sense, this is a program which has a great impact on social mobility. It permits to, some of these students are invited by private schools, the other ones start to study by themselves, and they can, with our programs, which I presented briefly, enter to your university and have a career, exploit their talents. But the most important thing, impact that these Olympics have, it's when a teacher in some school start to prepare and to train his students or her students to the Olympics. So here is Antonio Amaral. He's from Piauí. So maybe let me show you on the map where Piauí is. It's a Poo, so it's here. It's a Poo state in the northeast. And as I told you, the Olympics started in 2005. So his school got 1 bronze medal and 8 mentions. And then he started to prepare his students for the Olympics. And as you can see, well, the results started to increase up to a point in which they started to get 4 or 5 medals, gold medals each year. So this is essentially due to his training program. So what he does is, when the students start at the beginning of the year, they propose to those who wish to participate in this extra class activity where he takes previous problems or problems that we send to the school. So as I told you, we prepare didactic materials. So every year we send many books with problems similar to the problems that they will find in the Olympics. And he proposed these problems and start to discuss these problems with his students. So I went to visit the school. I talked to Antonio, and what surprised me in Antonio is that he told me that, well, he never solved these problems. He had no time to prepare, so he just proposed these problems to the students. And many times, the students were able to solve the problem before him. So you need teachers. Of course, I'm a researcher in mathematics. When I have a student who solve a problem before me, I'm very, very happy. But in high school or in elementary school, that's not the case. But he's accepted this situation, and he's handling it very well. And you see the success he's getting at the Olympics. But of course, I'm not really interested that the school is doing well at the Olympics. I'm more interested in what's happening with all students, not only those who take part in the Olympics. But the effect you can see in the next slide is that, so IDEB measures the students on the 9th grade. And you see in blue the evolution of each school. So, well, we have a national exam, and this is essentially the grade the school gets at this national exam. So you see that they started. So the goal of Brazil was to reach level 6 in 2021. So in red, you see the evolution of the country. So we won't reach a level 6 in 2021. That's clear. It's growing, but very slowly. Well, in Cocal dos Alves, this small town in Piauí, you can see here how in the 9th grade, how well they are doing. And on the right-hand side, we have a national entrance exam for the universities. So it's a patronized exam. 500 is the mean value. 100, it's the standard deviation. So getting a grade above 600 means that you are one standard deviation above the mean. And you see here in red the result of his school in mathematics, and in blue the result in Portuguese. So you see that, well, they started essentially from the mean value. In mathematics, now they are essentially above one standard deviation, while this is not observed in Portuguese. So you see that once you start stimulating your students to participate in the Olympics, giving prizes to the students who are qualified for the second stage of the exam, you can create in your school a dynamic that, well, it has an impact in the grades in math of all students of the school. So I think this is what we are trying to promote in the Olympics. It's that trying to stimulate teachers in preparing their students. We have not been very successful on that. It's very hard to stimulate teachers, to convince them to repeat what Antonio is doing in Cocao, but some of them are doing. So if I'm going to Acre, which is in middle of the Amazon, close to Peru, because there is a school there who got 2 gold medals in the last 2 years. Acre never got a gold medal, and now in the same school, there are students getting medals. So it's clear that there is a teacher there who is preparing his students, her students, I don't know who that person is, to the Olympics. So I would like to know what's happening there. So I'm flying to Acre in August just to see what's going on there and to try to repeat this model in all Brazil. So I think I'll stop here. Thank you very much for your attention. And well, please contact me if you would like to organize something in your country which is similar to the map. I'll be very glad to help. Thank you very much.
Thank you, Claudio. Thank you so much. And really, it's wonderful what you're doing in Brazil, really. So I have 3 questions that I prepared, but I think it's really good because it's real. You will have the occasion to speak more about what you are doing and your experience. Here is my first question. We know that mathematics seems to be a closed discipline. It gives the impression that one should be particularly gifted to understand mathematics. And the discipline seems also to be dominated by men, with very little room for women, but also very little room for other continents like Africa or South America, with their particular knowledge or ways of thinking about the world, or less room to minorities. So what is your opinion? What should the mathematics community do to make the discipline more inclusive and more diverse? Claudio.
So that's a tough question. So I can show you, for instance, what happens with the gender gap in mathematics at the Olympics. And I would like to present 2 graphs which get some information on what's happening. So what the first graph presents, it's here we have the percentage in the 3 levels of girls which are classified to the second stage. So you see that in level 1, it's in red, level 2 in blue, and level 3 in brown. So let me make it greater. So, and you see that it's essentially around 50%. Not really, you see that well, here there's a strange thing happening. Only 42% of the students were girls, but well, they are pretty well around 50%. But now if you go to the percentiles in the second stage, what you see here is, and let me go directly to the 90 and 95 percentile. So this is the 90 percentile. So we see again in red level 1, so which are students in the 6th and 7th grade, level 2 students from 8 and 9 in blue, and level 3 students from 10th to 12th grade. And this is the percentile 90, which means that we take the 10% best grades in the second stage. And what you see is that, well, at level 1, which is in red, well, it's not 50%, but it's not far from 50%. But once you go from level 1 to level 2 and from level 2 to level 3, you see that there is a big gap. So which means that very young girls are doing well in the second stage exam. But girls from, so level 3 means that you are between 15 and 18 years old, they're doing much worse. So we have to understand what happens with the girls when they go from 10 to 18 years, why they perform not so well when they grew up. So this is one thing to be understood, and which may try to explain the gender gap. So we have just the numbers, we don't have explanations for that. But then there is a second one, which is even more striking to me. And I really don't understand these numbers. So as I told you, in phase 1, we have 20 questions. So the students can get from 0 to 20 points. And many students don't go to the second stage to do the exam. While it's a Saturday, they prefer to stay home, they prefer to do something else, so they don't go. So here, what I would expect is that the better you perform on the first stage, the higher your chances to participate at the second stage. And this is what is shown in this graph. In blue, you have the women, the girls, and in orange, the boys. And what you see so among boys is that indeed, if your grade on the first stage, which goes from 0 to 20, increase, well, what you have here is the probability that you'll go to the second stage. The probability that you go to the second stage increase until level, well, grade 14, at which it's slightly constant. And here there's it's decreased. I don't understand why. Probably because the schools do not report correctly the grades of the students. They tend to say that they obtained 20, maybe they got only 17, but they report 20. And this is why this curve decrease in this between 18 and 20. But for the girls, what we observed, it's something completely different. So you see that starting from 10, you still increase between up to 12, but then you start decreasing. So a girl who obtained 16 in the first exam has the same probability to participate in the second exam as a girl who obtained 10 in the first. And this is this increase also the gap. This is the gap in level 1. So girls from 10 and 11 years old. So you see that there is a gap between the participation on the second stage between boys and girls. But this gap increase a lot if you look at level 3. So girls from 15 to 18 years old and boys from 15 to 18. There is a big gap. So why girls who obtained a very good result on the first stage don't go to the second stage? These are the girls who could get medals, but they simply don't go. And the same thing can be observed about, now you see, you compare the grade in the first stage with the grade in the second stage. And you see that, well, again, it's increasing, then here at the end it decreases, so probably because the grades are not correctly reported. This is for girls in level 1. There is a small gap, but there is a gap between the grades at the second stage and the grades between girls and boys. But if you go to level 3, this is even greater. So why the girls who obtain a very good grade in the first stage don't get the same very good grade on the second stage? One has to understand that. And then you said, well, gifted. Okay. Well, I think that the main problem, at least in Brazil, is that, well, it's clear for all of us, and this is general, that if you have a gap in your math formation at the beginning of your studies, that will reappear in all over your education. If you don't know how to multiply, you will have problems in summing fractions and so on, which doesn't happen in history, for instance. In Brazil, students from the 1st to the 5th grade learn mathematics with what we call pedagogues, and these pedagogues don't learn mathematics at the university. At the Federal University of Rio de Janeiro, which is one of the best in Brazil, I saw the curriculum. They have only one lecture on mathematics. So most of these pedagogues choose pedagogy because they don't like mathematics, they don't learn mathematics at university, and they arrive at school not knowing what they are supposed to teach. So that's a tremendous problem, because the kids arrived at the 6th grade without knowing, with the important gaps in their math education. And this will remain all over the formation. And mainly, I think, for this reason, they will hate mathematics, because they simply don't understand, because they are not able to understand due to these gaps they accumulate in the first years of their formation. But maybe you have a different view on that. I'm not really a specialist in math education.
Actually, what you are saying just reminds me so much the situation in DRC, in Congo-Kinshasa. But let me please go back to women, to girls. Is there any cultural issues in Brazil? I mean, is there any thinking about girls should stay home and do some household activities that could explain that when they are 15 to 18 years old, on Saturday, maybe the family are just saying you should stay home and taking of your sibling of the family or household activity. Is that kind of, do you think that kind of problem that you have in Brazil?
That's certainly an issue. Girls are supposed to take care of their siblings, take care of the home, stay home. So this is certainly part of the problem. So there is a big cultural difference on the expectations you have for boys and girls.
And is the government doing anything about that? Is there any program, official program, to address the situation and to change the situation for girls?
No, there is not a national program on that. There are some initiatives, local initiatives. So at IMPA, we try to stimulate. We have Special Olympics for girls, but there is no national program on that. But I mean, everyone is pointing, as you see, I have numbers and figures for that. So I would say that at least the academy is conscious that there is a big problem in this respect. But what's not so much studied, and I think it's also extremely important in Brazil, it's the race problem. So, and this is not being considered by the academy so far at the same level that gender is being considered. And there is a clear problem that has to be addressed. And but well, in Brazil, the society is quite mixed, so it's quite complicated to determine who is what. And maybe for this reason, these people or the academy is avoiding this problem. But this is certainly, I see on the training, I see on the ceremonies, there are much less Black people than white people among the medalists. And this is a very important issue which should also be addressed.
Definitely. Okay, let's move on to our second question, Claudio, if you want, if I may. We know and we are accustomed to thinking that teaching mathematics is a challenge. It's often difficult for mathematicians to explain what goes on in their heads. There are particular ways of seeing or manipulating mathematical objects. And there is this recurring questions of meaning. What is mathematics for? So in this context, how to make mathematics more attractive, how to improve mathematics education? Do you have any ideas, any ways that you could share with us, Claudio?
So as I said, I'm not a specialist. What we are trying to do is to popularize mathematics. And how doing that? Well, by proposing simple problems to not only to students, but so I have, for instance, a blog on one of the main Brazilian newspapers where every Sunday we propose an elementary math problem to everyone who would like to try to solve it. So problems similar to these from the Olympics, in which you don't need formal knowledge to solve them, but just an idea. And I would say that the real problem in Brazil will be to see how we can form better these pedagogues, which are so important in the beginning.
Teachers training.
Yes, because there is the problem. There is where the problem lies, and we have to address. So what I've seen to be proposed, which is education at distance, so that people, well, if the teachers are not able to teach, well, let's try to teach them through online programs. And we have seen during COVID that it doesn't work, right? You need a person on presence able to answer to them. So I don't believe in these, what's happening now in Brazil, which a lot of investment in education at distance.
Mm-hmm.
We have to make these pedagogues, people, to realize how important they are in our society, and invest much more on the formation, because the role they play, it's absolutely central for our society.
Definitely. Let me ask you a question about your research. Do you do anything to go, for example, to schools and to talk about what you are doing as a mathematician, about what you are doing as your research? Do you have this kind of activities to go and talk about what you are doing as a mathematician?
So we do have a program, indeed, so that stimulate and require professors, researchers at INPA and in Rio de Janeiro to once a year go to high school or primary school and to present to the kids what we do. So I don't know, it's very successful because it's quite difficult to if either you want to explain what you're doing, and it's very complicated to make it understandable to a person which has the knowledge they have, or then you try to give them problems which they can solve, but which are very far from your own research. So we recently, so the director of INPA, Marcel Viana, has created
Claudio, can you hear me?
You
Claudio,
don't hear me?
Okay,
yes.
I can hear you now. Yes.
I'm sorry. So we have been cut. I don't know. So what I was saying is that there is this festival of mathematics in which all the population is invited to participate. So they have talks by researchers, then activities to trying to popularize mathematics, trying to connect the population with research in mathematics. But it's very difficult. It's a real challenge to communicate. It's already very difficult to communicate to a physicist. It's even more complicated to communicate with a kid or a parent which has never studied mathematics. But I think it's a challenge that we have to face. And sometimes, so we have also a project to create a very big museum in mathematics in Rio, all with the same idea that let's try to popularize. Let's try to show that mathematics can be fun.
Definitely. So we could move on to our last question. The last theme that I would like us to address is the role of mathematicians in society. How do you think mathematicians can contribute to societal debates, such as creating fairer societies, respect for the environment, or mixing of people and culture, the production of wealth or ethics in scientific research? Or maybe you think that mathematicians have no role and that they should just stick to their research. Please share your view and experience about that.
No, I think that they have a very important role in society. So I grew up in Belgium and I studied in France. And I was always very much impressed in these countries how professors, university professors, were invited to share their views in journals, newspapers, on television. In Brazil, that doesn't exist. If you want someone to share, you ask a public person, like an actor or a famous sportsman, to share its opinion. Very rarely, a professor, university professor, will be asked to give his opinion on any matter. So we are trying to change that, and the Academy of Science is trying to stimulate, because also many professors refuse.
Claudio?
Be as much clear and as possible, avoid all technicalities and so on. So there has been a movement trying to approximate university professors to these newspapers and journals and so on. And as I said, I have a blog then in one of the main newspapers, and there university professors share their opinions on many different subjects. So there are two recent facts. First, the fake news. So now in Brazil, we still have a president who doesn't believe in vaccines. We had ministers who doesn't believe that the earth it's round, it's a sphere, they believe that it's flat. And so in this environment, our role becomes even more important. And actually, so the public opinion about professors, university professors, is very high. So we have a very important role, and we have to be very careful of not losing this confidence which is given to us. And we're trying to participate more and more in the public debate, trying to explain what's the point of view of science on different subjects. And I think it's very important, and this should be done in every country.
Definitely. Thank you so much, Claudio. I think that we have come to the end of this discussion. Thank you so much for your time. Ladies and gentlemen, thank you for participating in this panel. Thank you to Claudio, to our speaker. Thank you to the International Mathematics Union, the organizer of the ICM. I am Raissa Malou from the Democratic Republic of Congo, and it has been an honor and a joy to share this panel. Do you want to say something to end the panel, Claudio? A message that you want everybody to understand, to keep in mind at the end of this session?
Well, I think there is a lot to be done, and I hope that will be several in order to try to make science popular and to have a greater impact in our societies.
Definitely.
Thank you very
And
much.
let me tell you that the situation that you have described in Brazil is just quite the same as in Congo. So I think that it will be very good if we threaten the cooperation between the two continents, the South and South cooperation between our two countries, for example, or other countries, because there is so much things that are the same kind of issues that we could definitely learn from each other and improve the situation in our different country, in our different continents. So we definitely could stay in contact and continue to work together. And I think that there are many people who are listening to us who are just thinking the same and should be really happy to stay in contact with you. So thank you so much, everybody. Good continuation and bye-bye.
Thank you.